Okay. Okay. So at this point, Omar, let me get you. So at this point, I believe we're month 6, correct? And then we have one more month. So I believe the next 2 months, at the very least, one of these months is going to be new content. Yes, I would definitely say we got one more month after this, and basically we have 2 more exams, and that's pretty much it for preparation towards the AP exam. After that, admittedly, I have to find you guys some kind of project to do to keep you progressive, keep you kind of busy too in AP calculus. All right, but all the emphasis now is on AP calc, or like preparing for the AP exam. As well as that, I have printed up. I'm trying to find it right now. I have printed up AP exams from the College Board practice AP exams. I think some of them were quote unquote the previous year's exams, like meaning like from like 2006 2007. I think they just came out with something from 2017 to 2018, like from last year. But the catch is you guys can look at that stuff, but you guys can only look at it within this room, or else if I give it out and I distribute it, and definitely if it's found anywhere digitally by the College Board, like from me, like that invalidates all the AP scores on this campus for AP Calc. I can at least say that. I don't even know about the other AP exams. I just know, yeah, it's very, very strict. So it's really sensitive material. They don't want anybody discussing it outside of the context of a classroom. So keep that in mind. If you want to come in and you want to prepare and do the work, come on in. I invite you to. It's just I won't be able to tutor you unless it's like a formal tutoring time, But you can come in pretty much any time during the day. That's what I offer you guys, and just come in and just practice what you guys want. Okay? From those tests, yeah. Just don't take pictures. Don't distribute it. Don't do any of that. You can write it down, and that's that. It's your notes, but okay. Okay, questions.
Yeah. So I think last year I don't know if I remember correctly, but after you took the bio test, we didn't have anything afterward.
What? What's up? You didn't have any?
Yeah, I don't think we went to class afterward.
Really?
Yeah.
Okay, I'll explore this with the other AP teacher. Okay, and see what.
If I remember correctly.
Well, after the AP test, we like nothing else.
Yeah, exactly, because we
I am fairly new, being an AP teacher. But ethically speaking, I don't know if I should keep going. I think you guys should keep just going education-wise. And if you're an AP first semester, you should be doing something towards AP calculus this semester. My belief. But let me talk to the biology teacher, okay, and see what she did. And if that's just common culture here, then maybe I'll follow along, okay?
Imagine what I can do next hour.
But we're seniors.
I might do summer semester.
Huh?
I might do summer semester.
Yeah.
Yeah. I'm out.
I got you. Okay, Omar.
I took 2 AP classes with Mr. Sharp, and he did the exact opposite. He did give us a project right at the end.
He did or didn't?
Stop.
Well, I did that. I did that last year. Yeah. Did you see Benjamin? Okay. Omar, did I give you your exam? I did, right? Okay. All right, guys. We got to move on to new content today. We're covering 2 sections today. I'm gonna give you guys a warm up really quick, so please follow along. Let's see. Whoops. I gotta open up my program really quick. Okay, so I was very happy with your guys' performance. You guys did a really good job, all right, on the exam. It was really tough, okay? I'll give you the range of like what the curve was, and then as you're working on this warm up, okay? So this is 7-1 slope fields, okay? Slope fields. And the first topic that we're going to cover is it's going to be solving differential equations. Sorry, my writing's kind of messy. Differential equations, and then here's your warm up. All right. You must find all functions that satisfy dy over dx being equal to 5x to the fourth power minus secant squared x. And that's all I'm going to give you. This is going to be your homework, okay? I want you to kind of be, immersed in AP calculus vocabulary or vernacular. And I want you to try to interpret what this means. The thing is, you guys can talk to each other in this context, right? But we need to start looking at this from the eyes of what you're going to see or what you may see on the AP calculus exam. If you're given this, do you know what this means, right? So try to dissect what this means, okay? All right, guys, I'm going to give you guys like 5 or 10 minutes to try to figure out what this could possibly mean and find the solution. I'll say this, you're fully capable of doing this. This is not like amazingly hard. This is not a trick question or anything by any means. It's just tricky to dissect, okay? All right, guys, I'm going to give you guys 5 to 10 minutes to work on this, okay? And guys, can I ask you guys to please go on the board and work on this? I want to see, please. I want to see it gives me a quick glimpse of like where everyone is. And please, erase everything on there. I'll give you guys whiteboards. I got a lower No, I know. Sending you mixed messages, right?
Mr. Weed, get us over on permanent marker.
Oh, did they?
Yeah, look at it.
It's okay. Usually water as a solution solvent usually takes it off pretty easily. Oh, be there in just a second.
So this would be.
And then in the meantime, I'm gonna put up the curve too as well.
No, that's.
It was so.
Oh wait, because the fire is already there.
Actually, it's like kind of dead.
Oh yeah.
I could go in this door with like make it worse. Think about where Mexico was or where Peru was.
I think it's square x.
Over visa.
The antiderivative? Yeah, I think it's tan. I'm not sure.
Water is a very just water. That's good. Pure water. That's just pure water. No, nothing else too.
The anti.
So it's the antiderivative. Is that it?
So, oh yeah.
Wait, no, there's no antiderivative.
That's fine.
Yeah.
If you need, you can use your cheat sheets to help yourself, keep your language appropriately. And it's scholastic with educational advice.
For our project.
Hey,
You can look at the video. You want me
If
to
anyone needs more erasers, I have them up here as well.
Oh, shoot. Wait.
Why do you have
because it was just like that, and we just told it.
Hey, Mr. Spiegelberg.
What's going on? Yeah, I love that. Can we see it? You said it's on YouTube, right? Yeah, it's on YouTube. What's it called?
You're not though. Like,
I don't think you'll be able to find it.
Yeah.
I'm just thinking
Ben, where you been? We've been
God, Ben, come on.
Good to see you, Ben.
about your stuff.
Hi, Spiegelberg.
All right,
Hi,
Mr.
Spiegelberg. Still gonna give me an A.
Do you need a longer one?
How many you got?
I got this super long one over here. Here, I'll
Yeah,
give you a long
that'd be great. Can I have this?
one.
Two Liz. Both of those would be good. I think that's all we need. Yeah, we got a lot. I feel like there's something to try to get back.
And I got it right. That's wrong. I really like
We were scared about you. We were scared for you. We were scared. Oh, Benjamin.
I need a 2% buff.
Okay, sir.
Oh, I think it would be negative.
Okay, so what did you guys end up getting? Okay, so what did you guys end up doing for this problem? Why did you take the antiderivative for this?
Because the derivative of that equals that.
The derivative of your function, which you wrote as x to the 5th power minus tan x, tan just tan x actually, plus c. Okay, so why did you decide to take the antiderivative? Again, I have to ask you why you decided to take the antiderivative, and then you said this was the answer for this question, to find all functions that satisfy this derivative. Yeah, Christina?
The answer that we got, if you take the derivative of that, you would get
What?
that.
This statement here. Okay, and that's the function, correct?
Right.
A function, f of x, is also equal to whatever your y is going to be, right? Which is equal to this statement.
So basically, it's asking for a function that when you take the derivative
Mhm.
equals 5x to the 4th minus c.
That's brilliant. And plus, what part of this equation this formula this function that you came up with satisfies this notion here to find all the functions?
Yeah, plus c. So even if it could be any constant added on the end, and it just kind of goes away when you take the derivative because there's no x.
And just to ask, what is that c going to do to this potential graph? Like whatever the shape is. So again, fictional shape. I don't actually know what this is on the top of my head. Okay, squiggles. Okay, and this is on this coordinate. What will c do to this potential shape of this function here? Yeah, it'll move it up and down, or just the whole point is it'll translate it somehow. Okay, so all functions that satisfy this. Okay, so that's very, very good. That's going to hit about 2 different themes in this section that we're going to talk about today. Okay, in fact, why don't we actually? I'll give you a scenario where you have to solve for c. So what's that going to look like? So they're actually called these, like in that context, these types of problems are going to be called solving and initial. I think it should be solving for an initial value problem. That's okay. Solving an initial value problem. Initial value is like in quotes, I guess you can say, like an initial value problem. Okay. So it's the same thing as you were doing before. You would find the antiderivative, right? To give you a function that satisfies like maybe a derivative statement. Okay. But I'm going to give you some initial conditions. That's why I call it initial value. Okay. Some initial conditions in this way. So we're going to say, here's an example. Okay. It's going to ask you, you're going to be given questions in the future that ask you to solve the initial value problem explicitly. Okay. Solve the initial value problem explicitly. And then what it's going to say, or it might give you like a derivative statement here from a function. So it'd be 3 sine of x. And here are the conditions they'll give you too. Like they'll give you not the conditions, but maybe a possible set of conditions they might give you that you might see. And you know that if y is equal to 2 when x is equal to 0. Okay. So just think in your head, what are you going to do with these 2 values? You already sort of know what to do here, solve the initial value problem explicitly. And they'll ask you too to find maybe a function that satisfies these conditions. You've already demonstrated to me that you've been able to find a function that, that satisfied this scenario with this derivative, right? When dy of dx is equal to something. It's the same scenario here. It's just, what are these 2 values going to do to this problem, right? What's the difference between this problem and this problem? You should be asking that rhetorically in your head, or at least trying to solve for that even, okay? But I'm going to show you what this means. So the first thing is you're just going to find the antiderivative. Nothing different here. So you're going to find the antiderivative. You're going to find the antiderivative. And what should be the antiderivative for 3 sine of x? Yes, that is correct. Negative 3 cosine of x. Okay? You can think of that 3 as just being, it was there since the beginning, and then but you had negative cosine of x, and if you take the derivative of that, you get positive sine x. Okay? But don't forget, we have this statement here plus c. But think about it this way. You have other parameters and conditions now. It explicitly says you have y is equal to 2 when x is equal to 0. First off, what is that even going to look like on the graph for this function? What does this mean? What is this? What is y equal to 2 when x is equal to 0? What is this telling us? It's just telling us that this is a point on this function, correct? So now, instead of up here where I said plus c, you have a potential function, right, that could shift and be translated, right? Because there's many functions, okay, with this function here under this parameter plus c, right? But here, this solidifies the position, okay? So like, let's just say here, this is my graph, right, for negative 3 cosine of x. It's really not. It's not an accurate representation. And that plus c could have translated it up and down, right? But if you give it a point, it locks it down into one position, okay? We're going to adjust the way this function looks by putting, by including this parameter they gave us. So basically, just plug in the x and y, okay? So here, you're going to have 2 is equal to negative 3 cosine of 0. What do you think we're actually solving for now? We're just solving for c, okay? Sorry to kind of fill you with so much vocabulary language, okay? If you need to know, okay, if I just had to break it down to a process, just with no context, if you're given y is equal to and x is equal to with the derivative, you just find the antiderivative and you have to solve for c, okay? In simple terms, right? Just simple layman's terms. Okay, so 2 is equal to negative 3. What is cosine of 0?
1.
Yeah, it's just 1. Plus c, and then you get 2 is equal to negative 3 plus c. Then you add 3 to both sides, and you get 5 is equal to c. And then now you don't have many functions, you have one function, okay? Up here you had many functions because of this plus c, right? Who knows what c is? You can plug in anything you want at this point. But down here, you have one function because now you have a definite value for c. You have y is equal to negative 3 cosine of x plus 5. Okay? Is that simple? Yes.
So the answer would be in a function or would be a value?
It would be a function, yes. So you have to include c because it doesn't explicitly just ask you what is the value of c. It's asking you solve this initial value problem explicitly. Yeah, I guess that doesn't really make it any more clear. Yeah, just your answer should be in terms of a function. Okay. All right. Let me give you an example. You guys were working this on the board. You know me. I love board work. Okay. When I assign you the problem, give me 1 second. Let me get the book. This is 7.1 Euler's method. All right, here it is. It's right from the book. Don't look at the blue. Here. All right, guys, do number 14 for me, okay? Good. 14. You want to do 15?
Too late. I already started. Okay.
Oh, I was covering up some answers. That's why. Yeah, that's why. Sorry. Seems arbitrary. I was covering up some answers. U-substitution.
No, there's one that's.
So yeah, you guys decided?
Or like we're gonna talk to this girl.
Okay.
The price is 12. So that'd be 600.
Wait, I think I'm doing.
All she does is like
See.
Alright, Ali, I think I did.
He said 14.
Yeah.
Why did you
Wait,
come
shouldn't we do?
Because we're doing 14.
No, 14, you nerd. Just kidding.
Oh,
We're all nerds, we're taking
True.
But
nerds
nerds
get
get
Before you go to the next math class.
Wait, so,
Yeah, that's fine. I know you
so,
That too.
so will it become +5?
Really? Is it? Oh, wow, cool. I'd like to think I did something with it, but I had it was
Just see what's what.
from day one. You always just been really good at all this stuff. All right, anybody need more time?
I do.
Okay, here, take your time. Yeah.
So since I had 4 and we
You're
come up with
taking
C,
all of the
we just
format.
add.
I'm
to it. So
sorry.
we have 5, right?
Just watch out because
No,
you're
that's
adding
correct.
C to the derivative of the function.
Oh, so it should be this one.
Yes, that's correct. You should be adding C to the function which you solve for.
Oh, it should be.
So you know how you solve for C?
No, he still doesn't get it. He's asking if because that's 4 and there's no x, that it should be a c, but it should be 4x because the derivative of 4x is 4.
Exactly. Yeah.
But that's not what he's saying.
No, he did that.
Oh, yeah, that's right.
You got it. Yeah. No, that's good. That's good. No, you add in that one. You're supposed to add in that one.
Oh, plus.
Why'd you erase the 1?
So you got it. Yeah. You got it. You got it. You're
Oh,
good.
you added.
Trying to spill my work, Mr. Sabotage.
Wait, I don't understand.
It's just a
Oh.
descent.
X equals 6 when x equals 1. What does that mean?
It's just argument and descent. It's not
I
sabotage.
think it means this. No?
Yeah,
Yes.
yeah.
Okay. Very good. Very, very good. Okay. You guys did amazing. 15, 16 are. I mean, I should have maybe chosen 15. It's a little bit trickier. So, and then 16 as well. 16 has to do with trig functions. Okay. All right. Now we're gonna get to. We were talking about the potatoes of the section. Now we're gonna get to the meat. The meat and the potatoes of the section. You are vegetarian or vegan. The potato and the cauliflower. Or, I don't know. I don't know what's a really good base for. I don't know. I'm sorry. Should be a lot more cultured, and less ignorant. So my apologies. Okay. Okay. So now we're gonna explore what the heck is a slope field. I don't understand what that is. It's actually a lot simpler than you may assume. What is a slope field? You're just a warning. When you read it in the chapter, it's going to look a lot scarier and a lot more intimidating, but it's a lot easier than you'd expect. Okay, so we're going to be constructing. So here's the third and last section or subsection in this 7.1 section. Slope fields is finally constructing slope fields. So what is this exactly? I'm gonna write in what this is. It's when you're only given a differential equation, like a derivative, okay? Differential equation. And yet we want to produce the graph of a general solution. Uh-oh, what does this mean? Oh, yeah. Okay, so before we move on, what does this mean? What is this asking us in terms of what you guys were working on like the past like 30 minutes or so, about 20 minutes or so, like 25 minutes. What is this asking us to do? What is this prompting us to do? If you're given a differential equation, and yet we want to produce the graph of a general solution, what could that possibly mean? Yeah, Deja. Sorry.
Would we be able to pick any of the solutions from what the antiderivative is?
Yeah, and
then just graph it, because that would be a general solution.
what's the general? Well, general solution means something with what we did. Well, I mean, we kind of did it in the second section, but more in the first, like the warm up. Okay, yeah.
Would it be almost like we're kind of like drawing a bunch of graphs on top of each other, like infinite amounts?
Why would we draw a bunch of graphs?
Well, because it's a general equation, which means, or function, which means that it's not one specific, but it's all of them.
And can you show me on the board what a general solution would look like, or a general function?
It's like the C.
The plus C. Remember how I told you that the plus C shifts the graphs a bunch of times depending on what your C value is?
Yeah.
Guess what now? We get to draw a graph for that general solution. What if it was just plus C and I never gave you a point? And you had to construct all the possible graphs. Okay? So I'm going to give you what is it? Mathematicians that practice calculus a little bit more, what their solution was or what they created, okay, universally. It's called a slope field. And it's not that bad, okay?
Is it a field of slopes?
It's a field of slopes. It is literally a field of slopes. Are you ready for this? I think we're ready, right? Okay. I'm going to draw, first example. I'm going to say this is your example, okay? And I'm going to ask you to find, or was it? No, not find. Let's see. Produce a graph for the general solution for dy for dy dx is equal to x. Now you might already know immediately what the function is, okay? But what would it look like if you had to do a general solution? What is the antiderivative of dy over dx?
X squared.
1/2 x squared.
Yeah. 1/2 x squared plus c, right? Plus c. So we have to graph this basically, but with consideration plus c. So just label your axes really quick in terms of the intervals. We're just going to go by ones. And it looks like we're going to plot points, but we're not going to plot points. We're going to construct slopes at each point, if that makes sense. So let's see. At this point here, 1, 1. This is 1, 1, right? What would the slope be at 1, 1 for this graph? And not to confuse you, but you do not need this. Just given just the derivative function here. What is the slope, or what is the slope value at this point? How did you know that?
Because the derivative is a slope.
Yes.
So it's telling us the slope.
Is
So you have the answer right there.
Exactly. Okay. So what would that look like? What does the slope of 1 look like?
A small upward line.
A small
Yeah.
upward line. Okay. How about over here at 2, 1? What would the slope be now?
2, 1.
What would the slope be at the point 2, 1?
Oh, 2.
What would it be?
Positive still.
Positive what?
Still positive.
Still positive, but what is the actual value?
2.
2. So what was the slope going to be? Looking like. Okay. How about at 3? 3, 1. I'm sorry. At 3, 1.
So the slope's going to be
3. Okay. And then you see it's getting steeper, right? You got to do this for every single point. Not every single point, but most points. Okay. we'll just do it like for a few points around here. Okay. How about let's go to the next line at 2, 2. What is the slope going to be there? How did you know it was going to be? Oh, I'm sorry. 1, 2. 1 or 1, 2. 1, 2. Right here. It's 1. So the slope's going to look like this. And then here, how about at 2, 1? How about at 3, 2? 3. And then 4. Sorry. Okay. You might already pick up a pattern here, so I can save some time. But how about here at 1, 0? How about on the x? Okay. Again. At 2. I'm sorry. 2, 0. How about at 3?
4. I know how to count, Mr. Bush.
Okay. Well, I'm just asking, what do you think is going to happen if I just keep going line by line?
It's gonna stay the same.
For this particular solution, it'll stay the same. So you know what? Straight down, I'm just going to do a bunch of slopes of 1. Okay.
On the actual AP exam, would we have to?
You may actually, yeah, they might actually ask you to construct a, a slope field. But it's a lot easier than you'd expect if you remember how to do it. Okay.
Probably on an open response. Right?
Yeah. Open. Yeah. Multiple choice would be like draw it and then pick it. That'd be funny, but no, I don't think they would do that.
Well, maybe it would be like 3 options or 4 options. Like,
Oh yeah, I guess.
Yeah, that's true. That's true. You don't actually have to draw it, but for some reason, I just dreamt out the scenario really quick in my head.
Mr. Lee.
Yeah?
Can you do like another Friday teaching lesson thing, but make it like an AP test prep? You know what I mean?
Sure.
Where you just go over certain questions.
Yeah. I think we should schedule that.
I
Yeah.
feel like that'd be really helpful.
Well, what do we do that in regular classes though? The same? Like if we take the NP
We only have a class a week, though, so we probably only would get 2, maybe 3 tops of that,
Yeah, but like if we have like a whole bunch, right?
which would be 2, 3 tops.
4.
Yeah, we'll have like a little workshop where I think just come in with your problems.
I need all the help I can get.
Yeah, you know what? We'll make it like pretty interactive too. We'll just like come in and we'll just work with each other too.
Okay.
And like I'll tell you like and whatever I think is like a really big issue, I'll like stop class. And, yeah, it'd be kind of fun. Yeah, we could do that.
Thank you.
Okay.
I don't mean to put more work on you.
All right. How about the other side, guys? Like
Same thing, but pointing to the left, up to the.
All right. So let's save some time and I'll just construct like -1 slopes here. Does everybody understand why these are -1? Because I'd plug in.
Because it's a parabola.
Yeah. Yeah. Actually, you're absolutely right. They are parabolas. Okay. The next one should be -2.
You don't have to go.
Oh, I'm going. I'm locked in. I'm sorry.
All the way.
We're going all this route.
Shouldn't the little dashes be closer together?
Shouldn't this like be changing?
Guys, I'm so sorry, guys. I'm like lost right now. Okay, I am lost in the slope field.
Yeah.
So yeah, it's supposed to be changing. I'm not doing a very great job drawing. In fact, I'm kind of losing.
Great, Mr. Lee.
No, it looks
Believe
like what
in
it looks
yourself.
like in the book.
Yeah, it
looks
looks the
fine.
same.
Okay, good. All right, and I would do another column. But do you guys see generally the shape
Of a parabola.
of a parabola, right? At any point, at any translated point, right? So this is the general solution to this problem. Now you got to create one. Free response time. Are you guys ready? The reason why this is very helpful is because what if they asked you for something like this? What if they said same thing, okay? But what if they gave you this? It said -xy. Oh dear. -x over y. It sounds tricky, but what do you do at every coordinate? So let's say let me help you get started. At 1, 1, what would be the derivative? How did you know it was -1? What did you do?
Just put the x and the y in.
That's it. Okay. You see how the equation, the derivative equation is -x over y? You don't have to solve it. You don't have to do anything with it. All you have to do now is you just take a coordinate like 1, 1, and you plug it in 1 and 1, and then that's what your slope's going to look like, or what is. Okay. Now find out. Now this is going to be fun. I want to see this on the whiteboard. Okay. You and a partner, right? You and a partner.
Okay, that takes a bit of time. So,
It's gonna be very intense. Trust me. I want to see what shape you guys end up seeing or the function.
Want to work with them? Make your own side.
Yeah.
Wow, you're wow, Ben. You got a big smile. Do you already know what the shape's gonna be? All right, that's fine. All right, so just if you guys want, just erase all that and just create, learn and create.
Not a straight line. And so everywhere we're going up, it can go down. So all the positives. Positive top and bottom.
You look pretty.
I want to shoot perfectly. Look at that color difference.
I think 4x4 works.
I know.
So
Why did you
one
just
would
do
be-
that?
Alright, listen.
Did you do the line? Okay.
Listen, Ben.
Ben, you didn't do line thing.
You have to do the little line. Alright, so
Okay.
X and Y, right? It's
So
negative
here
two,
it would be
positive X
negative
and Y, yeah, negative
You can connect.
We can draw it.
negative.
Did something just pop in your head, Ben?
So you just
Like,
go
did
off
you
of
figure it
one.
out?
So it's always constantly going like this.
It's crazy.
What is
No, you're right,
What,
I just
X
wrote the wrong way.
one and Y
It's
equals
negative,
one.
I know.
It's 1/1. Negative one.
Yeah.
Oh, yeah.
This will be tricky. I would go by quadrants. All right. Yeah.
We're filling all the quadrants.
Does that make sense?
Yeah, because you need to see the overall shape.
So, listen, so if there's two
My
negative positive on that, yeah. And then two, okay, so you have in the
No,
quadrant,
what you asked
look,
me
it's
to-
positive, positive, negative, okay? If you have one something negative and another negative. Yeah, basically it's everything.
If I don't understand what
Okay.
So, let's take this point negative 1, 1, right? It's negative, so you have negative 1 over negative 1. Okay, this itself is negative 1,
Yeah.
times the negative is what? So negative, positive. This quadrant, so it's gonna be positive.
How far to each direction do we have to go?
That's it. That's fine. What you have is good.
Y is
Okay.
one way.
So you have to check for each quadrant.
Yeah.
So
Um,
yours are in positive direction because they're negative.
Boulder Cindy.
Yeah, I was like, are we doing it wrong? Because usually that's right.
Yeah. So we're like, wait a minute. I just like that. That was funny. That procession.
Alright, so
I'm gonna
negative,
check.
negative.
We don't look right. Negative, yeah, no. So I'm
No, I'm
gonna
not gonna draw
be negative 1.
Same thing as the right side.
Negative 1.
If you figure out what the general shape is, don't say it out loud, too loud. I want everyone to kind of discover this on their own, what this is.
Oh, it's we didn't do
So it's negative.
I would recommend, just doing a few of the bottom ones. Maybe not all, but a few. Just a few of the bottom ones.
Negative for me.
I would continue. I would not stop. Go to the other quadrants. Yep, you got to keep doing the other quadrants.
So now what's no.
Please do not skip on this. Do each quadrant. Do not stop at the top half. Okay, go to the bottom half as well.
Look at the first quadrant, it's just a positive negative slope. So you do that.
That's good. I'm really excited about this.
Does that make sense?
Yeah, it makes sense.
What am I teaching? No, just kidding, I would fail.
I would agree.
Hey,
You were the
you.
teacher.
I think you'd be fine.
I can teach kids how to skate, but I can't teach them math.
Okay.
You can teach it. If you can teach him, you can teach him. That's enough.
We're a good
Talk.
team.
There we are.
That's funny. So we were right. We got Alex's thing.
Alright, so look, you have a positive, a negative, and a negative. What do you get?
Is this satisfactory?
Really?
How much do we need to do?
That's fine. Do you generally see a shape there?
So like,
Draw it in.
Why are you struggling so much?
That's it, yeah.
You guys only have to do three.
That's it.
Yeah, I have a question.
Yeah.
Are you supposed to have like on these bits like draw the like
Yeah, you are. So I didn't do that. For some reason, I did not do that. Yeah. You're supposed to have the flat slopes here.
Mr. Lee,
Yes. What's going on?
this marker works fine. It's just down. Do you want me to keep it?
Oh, yeah. Just toss it out. It's fine.
It works good.
they all look the same.
We can keep it, but it's, yeah. All right. Yeah, we'll keep it. Yeah, conserve. Let's just conserve some ink here.
Maybe you should take it so the kids don't mess with it. That way you could be the only one that uses it.
Thank you. Yeah. I appreciate it. Do you see it? Do you guys see the shape now?
give them anything you want. Oh.
Wait, are these substitute?
I think so,
All right, and that's slope fields, guys. So, I mean, these functions will get more complicated, but at least it illustrates to you what we're kind of looking at here. So, what you create is a slope field. You created all the general solutions, so you can have circles at many different points, right? Let's see if I can. Yeah, am I gonna? Okay. So yeah, so you created a slope field with many circles, as you can see. You could draw a circle connecting a few different coordinate points at many different points. Okay, so this is a general solution this is a general solution graphically. Okay. Okay, so let's go ahead and move on to the next section. Okay, so you guys did wonderful. Good job, guys. This is gonna be 7.2. Anti-differentiation. You've sort of done this before.
Is this the substitution one? I don't know. Are you substitution?
Yes. By substitution. By specifically u-substitution. But to be honest, that u is just arbitrary. It could have been A, it could have been a B, it could have been a C. It's just universally we do use just u. We just happen to
Substitute you.
we can substitute u for a different letter.
No, you can never substitute you though.
You can never
Oh,
you can never
Oh.
thank you. Oh, it was really sweet. Yeah.
Mr. Reed, is that how
Thank
we
you.
get the names in class?
I'm just kidding. Okay, so here is a warm up, just really fast. You can do this. You don't have to run up to the board and do this. Okay. Find me the general solution, find the antiderivative for this, or just find the integral of x to the fourth dx with respect to x. Really quick, if you can. Okay. And please tell me what you've found. X to the fifth over 5. Very good.
Did we ever talk about the, I guess, power rule for anti-differentiation?
No, I
So
didn't.
if you have like x to the n, it would be, and you're anti-differentiating x to the n, it would be x to the n plus 1 over n plus 1.
All right, so let's establish that right now. So I know you guys been doing antiderivatives in your head, and that was a little bit of my fault because I never gave you a formal rule. But if you had to think about it, it's sort n plus 1.
1 over n plus 1 though.
1 over n. Oh, I see. I didn't do that.
No.
Yeah, you're correct.
Yeah.
Correct. Absolutely correct. Yeah. Don't worry. Yeah, I was about to say that too, Christina. I was like, no, wait a minute. Yeah, he's correct. Yeah. So I came to that same conclusion. Okay. So if you were to take the antiderivative of, let's say, x to the n, this is a general formula for like a kind of going backwards for a backwards power rule to find integrals, okay, or antiderivatives. You would have x to the n power, and then to take this, if you want to write this down, I would, but this was from the last month, right? The last unit. You would have x to the n plus 1, and then in front, your coefficient would be 1 over n plus 1, okay? I mean, if you don't understand what this means, you can look at an example here, x to the 4th power. The n is 4, so you would add 1 up here, and then you would have, if I had to rewrite this, it'd be a fraction of 1 over 4 plus 1, which we know to be 5. and that was your solution, okay? Or you could have written it as x to the 5th over 5, okay, if you want to go a little bit shorter. I like leaving it sometimes like this so I can kind of see sequentially the steps I took, okay? Okay, I am not expecting you to get this, okay? But how about a scenario where we have something like this? Take a stab at it. In fact, I'll incentivize it a little bit. If you find the antiderivative correctly without using this, the method I'm about to show you, okay, I will give you an extra credit point.
Whoa, okay.
Wait, if what?
If you can find the correct antiderivative, right, the correct antiderivative function for this function here, then I will give you extra credit point. But this is not going to be easy, right? We'll give you like a few minutes to do this, okay?
We have one more.
Wow, all right. You are super excited. I'm happy for you. Good person. I'm just trying to illustrate that this can get really tough mentally to try to figure this out without kind of formal steps to figuring this out. If you do figure it
I
out,
read about it, but now I forget.
what's
How
that?
to use, I read about how to use the chain rule with antiderivatives, but now I forget.
Well, hopefully with the method I'll show you in just a little bit, it adds formal steps to where you're doing those things without even realizing it, because it's so like you're just doing it by procedure, you know?
Oh, then thinking of it that way.
Yeah, so like that way when you're when you're doing this substitution method, you're already doing those things that you're considering right now, okay? Just adds formal steps to it, right? These formal steps will help you to make it formal in your mind.
Steering?
Yes, you're missing one element.
Let's see.
Yes.
You can take out a coefficient.
Very tricky, isn't it? Because there's so many things to kind of look out for and consider. And this is why this method, I'm going to go.
I keep getting confused that you can take out coefficient, but you can't put the whole thing back in if you take it out.
You're right, yeah. I mean, but I can't follow along with everything you're doing right now.
Let's see if we do this right.
This part is incorrect.
Okay.
Yes, but you're super close though. Yeah, you're super close. Oh, Aaron. Ben, did you already figure it out? No pressure. Yeah, I just didn't know because you seem like you have a lot of thoughts in your mind right now.
If I show you an answer, will you laugh at me if it's wrong?
Wait, which problem is it? Is it the one at the very bottom? Yeah. No. Wait, now I. No. There goes my egg.
What?
One extra credit point would have made.
Yeah.
It's close.
It's a new semester, dude.
I just want that egg.
I guess you know it's weird.
They call it age, not easier.
That's funny. All right. Do you guys want to kind of stop, or you guys want to? Okay. Aaron, no pressure. Can you just show us on the board maybe your thought process and see if we can relate? Okay. Oh, sorry, that was a weird way of putting it. Can you just put on the board what you were thinking when you're creating this, all right?
Aaron, you don't even need it. What are you doing, child? I need it.
So maybe it could help some people, not everybody. Maybe it could kind of help with how you kind of thought about this problem. I don't know.
So what's the problem? So got 4x. Or, sorry.
It's x to the 4th. So sorry. Yeah.
Yeah. So if this we would replace with u, right? Then we'd have to have a du in order for it. So we couldn't differentiate, for instance, 4x.
Oh, you actually use u-substitution
Yeah, I
already.
thought we weren't supposed to use.
This
I haven't even
because you're still
formally
having
taught you
x.
this. All right, that's fine.
So you have to find a du, and conveniently for this problem, I'm pretty sure we'll set up this way. This is the derivative of that. So your du is this. So you can substitute this with du. So you get integral of u to the 6th du. And then you get u to the 7th over 7. And then you go x to the 4th.
Actually, you're super close though. Hold on, it's not quite correct. I'll show you in just a second what it's gonna look like. Yeah. All right. Don't be like this is not a pride thing. Like I got it right, but okay. Who here still has problems with like understanding what this is? Okay, good. That's good. Okay. But do you have sort of like like you're trying to struggle to figure out what's going on? Correct? Like there's a struggle right now, right? You're attempting to understand what's going on, right? Because I just don't want you to sit and just be like, I don't care, you know? Okay. I just want you to at least try to figure out what's going on. And some parts are like kind of making sense and some don't, right? That's the thought process that should be going through your head because I'm going to formally talk about these steps that Aaron just did to solve this, okay? Yeah, Deja.
The only thing I don't understand is how did he know that the derivative of u was 4x? Is that like an anti-derivative rule that I
If you
missed?
take the derivative of this, you just take 4 out and then that's 4x 3.
Yeah,
and
so I
the
guess
4
that's
goes
just the
away.
derivative. I don't know.
No, you do. Yeah, that's correct. And
then
that was
in the
correct too.
chain
Yeah.
rule, you have to take like the derivative of this and then derivative of the inside function too.
So there's a lot going on. It's really messy right now, okay, in terms of our thought process collectively as a group right now. So let me try to attempt right now to add some formal steps to this and try to organize the thoughts that Aaron had. Not to say that you had disorganized thoughts. It's just we're having problems like following along too, right? Okay, because I'm picturing myself as a student right now, and it's like, oh, okay, he's really smart, but I don't really quite get this. Okay, so that's my thought process right now. Okay, because I wasn't as quick as processing stuff as you are here. Okay, so compliment day just yesterday, but compliment. Okay.
Oh, today's happiness.
Huh? Happiness. I'm not gonna do that, but great job. Okay. So let's go through the example again. Let's rewrite the example again. So I'm asking you to take the integral of 4x to the third power, x to the fourth plus 4 to the sixth power dx. Now the thing is, you already remember something about chain rule, right? And you know that you have to take the derivative with the sixth power here. And then you got to take the chain rule and take the derivative of the inside. There's a lot going on. So what you want to do is you want to take something that you know is you're going to have to apply the chain rule to, and you want to make it a u. Sort of like whatever is in here. And let's cross this out here. Like if this was just something to the sixth power, right? If that was just something to the sixth power, and you took the integral, then we know that'd be x to the, or that'd just be a block to the seventh power of 1 over 7. Could you do that? Right?
Yeah.
So that's what we're calling this block. We're calling that a u. The hard part is coming up with what your u is. Okay, that's going to be the struggle in the next few problems that we're going to go over. But right now, I could tell you this, that you want to keep it there? Okay. So no, it'll come back. Okay. And I take the derivative, it would d of that technically with respect to whatever that block is, okay? You would tell me that, or you would say that the integral of this would be this to the seventh power of 1 over 7 plus c, okay? That block, though, I'll just say, this is like a little side note, okay? We're calling this block a u. And then let me help you with this, okay? This is just a little side note here. Let's define a u in this problem. So this is just like its own little island of notes here that you can kind of think about. Your u, I'll assign, is whatever is in this parentheses, okay? That would be x to the fourth power plus 4. Just 4, that's it, okay? What I'm going to do is I'm going to write in 4x to the third power u to the sixth dx. I know I got all these other things in here to confuse you here for now, for the time being. But could you take the integral of u to the 6th power? Okay? Yeah, we could do that very easily. It's just this stuff that's kind of messing us up mentally. So why don't we go ahead and try to substitute in values that kind of clear this stuff up too? All you got to do is take the derivative of u with respect to x, right? Yeah, technically it is with respect to x, but we'll just say it's just du for now, okay? So du, what is the derivative of u? Whatever we called u. What is the derivative of u? Remember, u is, I just set u equal to this, so what is the derivative of u? Yeah.
4x cubed.
4x cubed. With respect to x, right? If you notice this, over here, 4x cubed dx, it doesn't always work out like this, but it happens to just be right there. So I could substitute these two values as du. So you're going to end up getting this. U to the 6th power with respect to u. This substituted for these values, because on the side here, sort of like on the side, you don't have to do this little wall here, but on the side, I've already established that du is equal to 4x to the 3rd power dx with respect to x. Yes.
But I thought you had to solve for d of x to plug it in. Like, because you took the 4x, like you took the x cubed out and took the d of x out and replaced with du completely.
Yes. So I'm not following along. So go ahead. Please show me.
So the way I did it, I brought both sides right, and then that's how we plugged in. So like I don't understand where you took out the 4x bit.
Because let's say if I did it, I'm gonna write it on a different piece of paper, okay? Just kind of like a diversion here to maybe a side note. So let's pause for a second here. Because you can do it either. So right now you came up with, this is what you did. Du is equal to 4x to the 3rd power dx, right? And then you decided to make, you wanted to solve for dx, right?
Right. So that's what's in the problem.
Du for 4x to the 3rd. I think I did that correct, right? And then our problem at, let's see, was at this stage here. We were at this part here, right? The integral of 4x cubed u to the 6th power dx, right? Let's see. So what you did here was you figured out for dx, and then you plugged this back in here, right? So let's try that. That's not a bad idea. Let's see.
It's a fraction. It's complicated.
U to the 6th, and then you'd say 4x to the 3rd times du over dx, or let's see, 4x. Oh, sorry, hold on. And I think that's a, let's see.
Oh, it just kind of, okay, well, I guess that works.
Yeah, it's not bad.
Wow.
Fancy.
So, yeah, so, like, that's how, yeah, but I don't understand you just, like, took it out.
Oh, no. I didn't take it out. I just, here?
Yeah.
I just left it there, and all I did was I just took this and I substituted in. That's it. So
It's multiplication, so you could use the commutative property, which I don't know if you're seeing it.
So I guess either way, it really doesn't matter.
I don't understand the first bit.
You can move
Alright, it's
everything
fine. I can
around.
use that way, right?
Yeah, it works out. I was surprised actually. I was like, yeah, I guess it works out completely. Yeah, because in the end, you're just gonna give me the integral of u to the 6. Can you give me the antiderivative of u to the 6th power with respect to u?
Yeah.
What would it be then?
1 over, or u to the 7 over 7.
Or yeah,
Let's see, yeah.
or let's see. Okay, so now all I have to do now, it's sort of like a mental way to look at this. Instead of looking at something as complicated as this, if we replace this with like a blob, okay, and you figure out what the derivative of the blob is, and you substitute in some things so it makes sense to you, it makes a little bit better visual sense to you, you're gonna end up with a nice simple answer that all you have to do now is you simply go back and then you just plug in what your u was in the first place. It's x to the 4th power plus 4 to the 7th power over 7 plus c.
Where did the DU come?
Oh, once I took the integral, that du statement goes away. Okay, because we're taking the antiderivative of the derivative.
I don't understand.
Maybe it's better to show my question actually.
Okay,
So,
yes.
If we had somehow gotten to a function where we end up getting like a sine, for instance,
That's the only part
this doesn't work at all. A sine of u, a sine squared u. Would you have to do another u substitution again?
What do you mean? I don't.
So like, if you're in a position where when you plug in u, it's still not anti-differential, would you have to do another u substitution?
Oh, like a sequential u substitution.
They're supposed to all work. It can be any.
So you could just keep going and plug in like a v or
Yeah, you could theoretically do that, but it's like coding. You can do all these u substitutions, but you're trying to find the most efficient way to do it. So it all depends on what you set your u to be. So if you make maybe the sine squared, whatever that statement was, and you make that the whole thing u, and that ends up being easier, you should do that. But so I don't think I 100% follow how deep your question goes.
If you have sine u, then you still can't entirely integrate that. So would you have to do it again and then have like a v squared?
But you can't.
I see what you're saying. Yes, that might potentially happen. Yes. So, but I think if we go through the next few problems, we're going to explore a few scenarios where it doesn't work out cleanly. This, guys, worked out pretty clean. Okay. It does not always work out that clean. Okay. But baby steps. Okay. So let's maybe take one step forward by practicing now. You guys ready? You guys want to practice? You guys seem like you guys are up for practice. Yes. Yeah. I said I'd prefer Friday, but if you need a day, email me. Yeah. Yeah.
Well, you know what?
This Friday or Thursday would probably work. Yeah. I think tomorrow would work. Yeah. Today I'm scrambling because I don't really have an 8th grader's lesson plan right now, so I got to develop one really quick. Okay. All right. What would be a good one? Oh, give me 1 second, guys. I think I didn't have a. What's a good one? What's a good one?
Oh, okay. I see the light. It was high. Let's do it again. You did it now.
Yeah. Okay. All right. As long as something works for you, Nathan, I'm happy.
Integral.
X to the 4th plus 4. It was pretty.
He wrote the whole problem.
Oh, you
That's why he lost.
You was confusing.
Yeah.
Let's see. What is one that works out?
I'm always first section. Yeah.
We went to Missouri, so we got our.
Well, because I had no.
Oh,
Nothing else I posted, so.
Oh,
Substitution two.
So then what was
Government
this?
or economics. Economics.
I think we're gonna have to switch out of books.
Yeah.
All right, guys. I'm gonna give you a. That one seems pretty hard. I just wanted something that was pretty nice. It wasn't too bad.
Like a dark shadow.
Okay, guys. This one's gonna take a little consideration here. Why don't we try number 20? Oh, we only have 5 minutes of class left, huh? All right, just give this a try for now, okay? Number 20, and then but pack up though at the same time because I think I'm gonna have to extend this this lecture, hopefully, and if I have time to make a few videos or at least post up a few links for a few more videos of different examples, okay? Because this is only touching the surface of u-substitution and how deep this can go. But as long as you got this, you have a good foundation of where to start, okay? So why don't we try this? It even tells you what your u is, but at this point now, you got to figure out the rest, okay?
Okay, so you know how we have to switch
Sorry, I should have froze that. Because there is one extra step here to this problem that I haven't mentioned yet. Ooh. Oh yeah, there's no. Okay, there we go. Sorry, I try to find a cleaner problem, but yeah, can't make heads or tails of this right now for what's a clean problem right now. So
What if you
yes.
the derivative of 7x is 7, and 28 is 7 times 3. So what if we put in a 3 at the beginning?
Or you can
And,
divide it.
a 3 on the inside. There you go. So if you multiply it by 3 and then put a 1 over
Let someone have it.
Mister, what's the answer?
Sorry, like I said, there is an extra layer of difficulty to this problem. Okay? I tried finding a cleaner problem. They're not super clean.
What's the answer to it?
Should be.
What? Okay, so
Oh, sorry.
so 3 times the integral,
Right here.
and then
Yeah.
7.
Okay, so that did work.
Yes, that works.
Okay, that works out. Okay. Fair
7.
enough.
Because this is basically 1/3 times 28, and what we would figure out.
What'd you get, good sir?
The 3, you can take out the
Well,
1.
if you multiply by the derivative, then I just plug it in.
Yeah.
Let's see, so this here
7, and then it would be.
plus this, so you have u.
Yeah, so there'd be 3 times
And then
the
because I'm
integral.
dividing the whole thing by 3.
It is, I believe, not correct.
Oh, it's not correct.
Yeah, it's not correct. I think, I overthought it too. I think you're actually overthinking it. Here, let me write up the steps right now. So you got, what is it? All right, oh, awesome. It's conveniently right there. 28, 7x minus 2 to the third power, right? dx. So
That's
you're,
right.
that's what I believe too. That's what I thought too. It's actually not correct. So let's work this out. So if
So it
you
doesn't
said
work?
u was, I thought we were gonna have to do that, but I guess apparently not. So 7x minus 2, right? So if you had u is equal to du would be 7 dx.
Is this the answer? I just made it up in my head.
So it'd be
I'm not sure because I didn't get the
Is that what
so
you
it's
got?
you have
sort of well
U
the plus c 3 and then
du
or c
right
and
now.
then multiplied by 3, but this is not right. So
Let's see.
we're
And if you
waiting for
had
him to
this
solve.
here, what was it here that we had?
So what we saw was that this 28 would be like 3
Okay,
times
so I
7.
think
So we took the 3 out because then we have a 7 in front of it, and if you take the
Here you
derivative
have
of
that.
the inside, like the
Yeah, I
derivative
know. Yeah, this is a bit
7x
weird.
is
Is it not
7.
right, though? The
So
thing
then
that's
we just
even-
took the antiderivative
I
of
feel like it's
this.
right.
so
and then
what
we
you're actually
multiply
looking
by-
at
Why don't
is
you think it's right?
to make this equal
I
equivalent
don't know,
here.
his answer said something different.
If you're let's see, if you're
What is the
this
answer?
was let's say
So this is
uh-huh.
kind of what I did. So I put a 3 because 7 is 1/3 of 28, right? So if you put a 3 outside, it cancels back out. Or
Come
it
on.
multiplies into
So
itself.
let's take the derivative of this really quick. If you take the derivative of
Is
this,
this the answer?
this would be
Can I see what the
7x.
answer is
What
again?
do I do now?
Sorry, here's the answer that we're playing right now.
It's
So hold on, 7x is to the
7x
fourth power,
minus
right?
2
You have
What's the answer?
3 over 4. If you took the derivative of this, you
4
would have
plus
this
c.
as your
I
final
have no
answer,
idea why.
That's
Use
the answer?
7 over 7.
the third power.
How do I
That is
know
not
this? I
actually
said
what we
four.
have. So this is actually
3 times 7 is 21.
21.
4
Oh,
times
you're right.
7
So it's a
is
4.
28.
Oh, whoops.
Oh my gosh. Then we got
Yeah,
the
so
right
that was
thing.
the-
Because then the 4's cancel out.
Alright, so
Okay.
Oh, you guys are having
That
multiplication
makes
issues.
sense. I know. So we did get the right answer.
Okay, so just 7x minus 2
Okay,
to the
that
4th.
makes
All right.
sense. Thank you. I can't believe that.
Are you gonna go
Alright.
over this on your video though?
Yeah, I think I have to go over this.
Because I have to go see Miss.
All right, guys. Sorry, guys. We're gonna have to cut class. I had some difficulty with this, so I'm gonna have to continue this on the video. My apologies, guys. Okay, so my bad. Yeah. All right, guys. You guys have a wonderful day. I apologize about that last minute goof up on my part.
So, Mister, when I do test corrections,
7x minus
do I have to do it separate, like paper?
No, you can do it on
write
there.
it on it?
You can do it right on the
Okay.
paper. Yeah.